right, 1, 2, 3. We're going live. Good day, everyone. Thank you for joining today. Today we are about artificial intelligence, specifically large language models. If you ever thought about perhaps how do I get into AI? How do I use AI for my applications? What are the advantages of AI? Hopefully, with this presentation, I can definitely give some answers to that. So welcome. My name is Oscar Garcia. I'm a principal software engineer, and I dabble into AI, data engineering, software engineering, and a few things. So I'm more than happy to have you today and speak to you today. Thank you for joining us. You can follow me using Twitter or my blog, oscari.com. I write about technology and different topics. So go ahead and give me a follow there, please. All right. So just housekeeping tips, please use the chat for relay back. Use the Q&A for questions. That's important because we sort of record the questions, and it helps us do sort of data mining to improve the presentations and so on. As usual, enjoy the presentation. Fill out the post survey afterwards. And definitely look at the resources that I posted the links on the chat. Follow those resources. You have all the material that covered is presented on the AI engineering repo. So all the code is there, and it's an evolved project. It just keeps on growing. If you also have interest on machine learning development, there is a repo there that gives you the basics, and there are some good projects about how to use different algorithms of machine learning algorithms, and how to understand and how that works. So let's continue. So what are we talking about today? So today we are addressing large language models, and this is not Skynet, right? We're not even close to that yet. But this is really a generative model that is designed to understand questions and text, right? And generates human text response. And all this is done because it is based on learning from a lot of data that is actually found across the internet, right? So basically, and this is how all machine learning models also work, right? They get all these large amounts of data and they train on that data, and that's how they're actually able to understand certain things. When it comes to these models, their foundation is really based off what they call foundation models, and those models really are just really specific models to resolve a task, right? So for example, to answer questions, to create sentiment analysis and things like that. So the way they work is they get text, they see images, they capture speech code, and they're able to train on that information, and they're able to generate responses based on that. Some of the common tasks are text and code generation. So basically, if you're asking a question, hey, how do I pay my house? How do I do certain things? It will generate an answer based on that. Specifically for us today, we're talking about generating code, right? So it is very good at doing that, just because it has gotten code from many repos like GitHub, Bitbuckets, and things like that, public repos that, where it's actually doing data mining and learning from what's out there. Natural language processing, that's also important, not just for reading text and reading, but also understanding voice, picking up voice and doing sentiment analysis, right? Also, language translation, translating between different languages like Spanish to English and so on, or translating Python to C# and so on, right? So also coding languages. And definitely for question and answering is very good at that. That's why it's very good for doing chatbots and things of that sort, right? So, Okay, so but what is the secret sauce, right? So we understand those models are there. How do they get there? How does that work? So the secret sauce for this really is that these models are trained on a combination of machine learning and deep learning. So that's why it's important. You can take a look at my machine learning repo as well. There are some areas about machine learning and deep learning and neural networks. So that will be helpful if you need to get some background on that. But the goal is that it trains on this massive data set, right, of information, right? And it feeds this information into a complex neural networks with multiple layers. What does that mean, right? What is this neural network with multiple layers? So in fact, a very simple is that image you see there where you see an input layer, hidden layers, and output layer. So that is really a sort of a presentation or representation of a neural network. But of course, this is very simplified, right? And every circle that you see there is actually called an artificial neuron. That's why it's called neural networks. And it attempts to think and process information just like a human brain can do. But this network really has a lot of hidden layers. And the meaning of that is that as you peel the layers, you see more and more things, and you can have embedding layers, encoding layers, decoders, and so on. So they all have meaning. We'll try to provide some insights on what that means, but as we continue the presentation. But the whole purpose of this is for this networks to basically analyze patterns, identify and analyze the patterns that are in the data, right? So it's able to map the inputs uh, to an output. So in our case, it will try to read the user stories and generate a code based on that user story, right? So, and what is the training process? So the training process was really very similar. This is really how all these AI models are built. It really starts with the data collection, right? So it's going to read this massive amount of information. Um, and it's going to process that data. It's going to clean it up, format it in such a way that it can be adapted to for machine learning algorithms, so that the information can be processed, right? And then the training is exactly where it's actually processing the data. Is sending this data through all these different layers and processing the output. And as it is, and it's a repetitive process. It continues to do that over and over, right? So because that is how it starts getting better at it. It starts learning and starts making corrections, and you can feed it more data so it learns more. And then fine tuning. So fine tuning is that process to make small adjustments on the models of how to learn about the data and how to process the data. So sometimes you fine tune that because perhaps the accuracy is not that high, the accuracy may be low in the 75%, and maybe you want to get that to 92, 93% accuracy, which is really considered a good accuracy for that model. But so now we sort of understand the training at a very level. How do we, I mean, how does these hidden layers really work, right? So, and these hidden layers really could be many things, right? But one of the most popular ones for large language models is really the transform architecture. And yes, it's not the Autobots, it's not that, but it's really just an architecture that it is very good at processing long sequences of text. And what it does, it really just grabs a very long blob of text or a long sentence, and it sort of and understands the relationship between keywords, right? So you may have, so basically, uh, you may have a long sentence like the boy that is happy in the mountains and smiling is running, right? And out of that, you may just learn that what's really relevant and important is that the boy is running, right? So that is what's called the attention mechanism. So that's the key to all of this, right? So this transformers really what they have is they're made up of, they build out encoders, right? So the encoder is really a layer that will grab this input. In this case, let's say user story. It will encode this information as it see fit for be able to understanding attention, like I just sort of mentioned, right? What are the keywords and what are the relationships? And the coders will actually do reverse to be able to generate the output, right? It will understand in the case of maybe user story that we're asking all this stuff about, you know, build me a code, but it knows that is the keywords will be build me a function on Python or JavaScript that does a this algorithm, and it will understand. Okay, and it will just map to what it knows from a source like GitHub that it has learned from, and it will generate a code that actually matches that input. And attention mechanism exactly what enables this kind of process, right? So if you want to, and the key here is to understand attention mechanism, and you can read the book that was released book back in 2017, and it just basically gives you this understanding of what that means. And it really what it attempts to do, it attempts to work like a human brain and sort of map these keywords and understand, right? Eliminate the noise from the content, from the input, and just focus on what really matters and understand that and process the information accordingly. But okay, so we understand these things, right? We understand how they work. How do we use them, right? How do we talk to them? What's the process to do that? And that's where prompt engineering comes in, right? So prompt engineering really it's a fancy sort of label that we're using. You know how we love technology coming up with new terms and labels, but it's really just that process to sort of be able to write something that makes sense, right? So be able to write a text that actually tells us or tells the model what to do. So, for example, you can't just really say, build me a function that does an if statement, right? That's very vague, right? That's very open. What does it really, what are you really trying to achieve? So it's be able to understand how to build this prompt so you can actually tell the model what to build specifically. So you have to be very clear and specific on your prompts, right? That's the key. That's a key feature here. And you have to do something called like task framing. So what that means is provide something specific of the output that you want. What do you really want to do? So for example, I want to write a class that does, I want to write a class in C# that does this, right? So that's very specific. And you can even feed it back some examples, as you may say, but I don't want you to write a loop because I want my function to have very good performance, for time complexity issues and things of that nature. So you can provide that those are specific details to help the model build what you're looking for. And definitely provide instructions, right? So provide instructions to say, I need to build this. So as an example, I hope you can see it. We're using the format of a user story, right? So if you remember, you've probably been working with user story where you see as a customer, I want to create something so I can do something, right? That's the sort of the template for it, right? So if we sort of understand that concept and we kind of use it for our purpose for software development, so it actually can enhance this in such a way that we can create a specific give it some technical specifications and be able to detail what we need to build. As software as developers, we sort of understand when we're building something what we need to do. So we understand that we need to perhaps create documentation for it, unit tests for it, be able to name the function in a certain way, use certain naming conventions, and what kind of parameters do we need, and so on, right? And we can create this user stories providing that level of details and complexity, so that we're actually not only writing sort of a specifications for what we're building, but we're actually documenting the entire process. And then as an output, the model can read all of this, learn from what you're trying to achieve, generate the code that would actually meet some of your standards, right? And produce what you want to do. So with that, and with that understanding, then how do we? But okay, so we write the prompts. How do we feed this into the models? What is the process, right? So I'm sure you use ChatGPT and Gemini before, and you probably open the browser and you kind of interactive, right? So behind this UI, the AI engines, right? There's really APIs that are that integrate with these platforms, and you're able to exchange information. So for our case, right, using the concepts and the principles of agile methodologies and user stories, because it helps us capture requirements, right? And for code generation, we can use this, and we can use something like GitHub, for example. And because usually, we use some kind of project management tools, repos, and so on, to be able to capture user stories, information, requirements, what we're trying to do. So we can write the user stories on GitHub or something similar. Our application, so we have to build an application that will interact with these models via APIs, right? So this application can really be the bridge between the GitHub and the AI, and be able to say, okay, I got these user stories, go ahead and send it to AI and generate the code for me. And it grabs that code, and it will send it back to GitHub as a comment, or you can even create another task if you want to, and automate some process to build the code. But of course, that's not the way to do it, just because the code that gets generated sometimes is not perfect. It will not be perfect all the time, but it's really a good starting point. It could be an 85% starting point of what you need. But the important thing is that it enables us to quickly build this out, follow standards, and be able to use it. So just keep that in mind. Oh, it's not always perfect. So don't think that is perfection is there. It's not. So how does that impact development, right? So how does that help us, in which ways? So basically, depending on how long you've been doing software engineering, right, there's always been a kind of a goal to accelerate development, to use some kind of systems and platforms and frameworks to generate code, right? But all these code generation tools of the past were not, they were really very hard coded templates, right? They were really not that good and flexible. You needed to change something, you needed to go code it yourself physically and use that template. So, but today with AI, we definitely can generate code just by expressing what we need, giving it specifications of what we need to do, and it definitely can help us for code completion, generate code, code refactoring. Sometimes you're looking at the code, it's like, oh no, this thing has like 5 loops. I can probably some kind of data structure, and instead of looping through all these different arrays or data sets, it definitely helps with something that a lot of us developers don't do: documentation, right? Improves the documentation to follow our standards, and definitely can maybe something was written in the backend using C# and now you need to move it to TypeScript. Then you can translate some of that code, and it helps you get started on that, right? As an example, you see here, this is a React component that was generated by Gemini, and it gives you a very nice documentation format for the headers and the components with themes and things of that nature. And it's all generated by Gemini. And this is sort of a very common way to generate components using React. But of course, security concern, just like anything, just technology, right? This thing keeps learning, progressing, and always you are going to have exploits, generate harmful code. So we have to be mindful of that always. That can happen. All right, so okay, so it helps development. How do we get going? How do we get started, right? How do we do this? So here we talk about, we introduce Gemini AI. So what is Gemini AI? It's really a large language model that is built by Google. It is basically similar to ChatGPT, if you have used that as well. And it's really built out. Its main components are really the Gemini engine, right? The whole AI sort of platform that has different models, right? And the different models will be the different type of models to build different things, like images, like voice, like text, right? So there are different models that you need to identify when you start using these components. And for an application to interact with it, there is the concept of an API, right? So the API is what we use, developers can use to be able to wire our code and be able to interact with the platform, be able to query and pass our prompts and get back our code and so on, right? And you want to visit, whenever you have a chance, Google AI Studio. And it's really a way for you to log in, create your profile, create a Gemini key. The key is necessary for the API access to the API. And on top of that, you can sort of test, play with prompts, and just kind of do some kind of exploration with the tool. So in short, we understand that AI is very helpful for development. It can help us accelerate our development process. It can help us build, definitely, as developers, data engineers, and scientists. We can use some of these models to create scripts, SQL scripts, Python, JavaScript, and actually our programming task. And part of the common task for AI, generative AI, is to do code generation, natural language processing. If you want to build applications that you can actually use voice for that, it can summarize books, papers. You can build chatbots to be able to do software to guide users, right? Be able to ask questions and guide the users to certain tasks. Key for this is understanding that behind the scenes there is the multi-layer neural networks, and there is a concept of a training process, right? It's learning from a lot of data that we feed it, so it's not magically just thinking and learning on its own. And the transformer architecture is key, right? This is key. This is what you will hear a lot, that continues to evolve with encoders, decoders, and most importantly, attention mechanism, which is sort of the brain behind it, where it's analyzing words and actually is paying attention to words that have meaning, or they have a very good relationship. Prompt engineering is where our AI, and we get code generation just for this use case, right? There's a lot of other use cases, but that's our focus today. So please follow the repo. Give it a. These are some of the technologies that we use. So let's take a look quickly at some code and continue to move forward. But I hope so far this is making sense. It's how, but there's a lot of stuff behind this, right? So if you join the, I hope you can see it. I'll try a little bit. This repo is designed to address AI engineering, which is really how do we build applications to tap into AI models, right? And this is really the approach here is to use engines like Gemini or be able to write applications, right? So, and you can, if you want to contribute to this repo, you can do that. One of the use cases here is code generation, and there are other ones that are in the pipeline. But here, what you want to do today, once you have time, you want to go to the Python. We're going to have Python for today, right? You want to go to Python folder, and in there you will see the code generation. You will see the code that actually works, and we'll look at it more detailed, right? And explanations, and also some of the services. So in the services, you will have some of the wrappers for the Gemini and the GitHub APIs and so on. Okay, so this is readings here for this project, and we'll take a look now using Visual Studio Code. For Google Studios, you can visit that. You can get an API. This will generate an API key that you will need, right, for you to be able to access the API. So that's right. Let's move on to that. So pretty quickly, this is really the same repo I was showing you. I hope you can see it. So essentially, you need some requirements, right? Python 3.9, and this Jupyter notebook gives you some of the directions of how you want to do this, how you want to build this, right? So this direction, it will show us basically how to detect your Python version, how to upgrade to it, how to install the new versions. And it's a little difficult, work if you have Windows or Mac or Linux. So that is very, we just got to find a way to upgrade it to based on your platform. But this is for Linux instructions, and of course you get your API key from Google Studio. You want to copy that key, keep it, and then we're gonna run a script. And the script, what's gonna do is actually gonna grab that key and create an environment variable with this key. So this is gonna enable you to now, instead of hard coding keys in your code, be able to use an environment variable, or if you use a key vault, right, to be able to secure your key. So and what you want, if you wanted to take a look at the at the code here, it's just really a bash file that will read them. It will for your key, and then it will create the dependency, which is it will update the bash resources, and it will just be able to generate an environment variable for us to query through, right? And so this just takes you through the environment, right? Key here, we use PIP environment to create and isolate the environment. So we are able to have different versions, right? So we can have maybe Python 8, 3.8, or Python 3.9, and so on, because some of them continue to grow so fast. They keep using the latest and greatest. So you have to upgrade to the next Python version or JavaScript, TypeScript version, and so on. Right. So, and you install dependencies, but this is really there for you. If you just follow the instructions, you will see some of the stuff on how to install dependencies. There's a file here called requirements text, and that has all, PIP environment, PIP file, I'm sorry, and the PIP file has all the dependencies, and you will see it here, right? So PIP file has all the dependencies, and because it's using PIP, and it will just read this and install this, and these instructions are basically saying how to use that, right? But anyway, so let's take a quickly look at code, right? Because we want to see some code here. How does this really work? So this Jupyter notebook really just gives you isolates basically into how you basically do it without the complexity of how do we write this complex code, right? Which we're going to take a look at that as well. But this one just really says, hey, just import this just Gemini library, right? Get my environment key, use this model named Gemini Pro, which is key, right? Because you can have different models that you need to use if you want to generate images or voice or things of that nature, or maybe the latest version, right? Gemini Platinum 2.0, right? So they keep on increasing, right? And just basically, hey, let me read my key. And by the way, one thing to notice here, if you're not familiar with Jupyter notebooks on Visual Studio Code, is that you need to pick the right kernel, right? You need to be on 3.9. That's the density of the kernel, right? So just make sure that if it doesn't work, all of a sudden you're working and this is not working, but you need to take a look at your environment, see what you have, and just basically, you would just run this by doing Control Enter, or you will just click on the play icon, and it will just process that information, and it will go ahead and do what it's to do, right? It will get the dependencies, the Gemini keys. Now you can just go ahead and use the API. So we can just go ahead and use the API and just generate something like, hey, we are running a presentation on this. Can you just tell us something? And this will just generate this code, this text from the model. It will just say, hey, look, right? And it just gives us something we already learned, right, that I talked about. But let's say you want to look at comparing prompts. So, and this is really interesting. This is what really show us, right, the capabilities here. We can just say, hey, write some code that select the biggest number from a list, and we can pass it. And the model's just going to give us some random text, right? It's going to generate some code. And we can take a look at the code. It's just nothing wrong with it, right? It's particularly correct. But it just feels like we allow the model to control what it needed to build. We did not give it enough detail. And we wanted to give it more. We want to be able to tell it, hey, just do this specifically, right? So that's where you probably need to, and of course you can run this, just say Control Enter, and hopefully my work is working, and this is not defined. So I need to input all my. So one thing with Jupyter Notebook is that you need to run all in, and I did not want to run it so I don't run out of time. but you know, you need to run all the cells, import all the cells, right? And be able to go ahead and run this, right? Make sure that all the definitions are predefined on the cells above. If you make changes to those cells, you need to rerun them so the definitions are reloaded, right? And it's just going and running and saying, hey, and this is coming from Gemini, right? This is generated by Gemini because we asked Gemini, hey, give me some understanding, right? So, but going back to the prompts, right? If you just look at this, it's the same thing. It's just gonna go and say, hey, write this, and it's just doing that stuff, right? Give it a more advanced prompt, right? We're saying, hey, write a specifically Python, right? Get me, name it, find max, take a list of integers as input, return the largest integer in the list, and we're building out more specific requirements or technical specifications. So now you can see the code saving. Now it has documentation. It documents the parameters, the return type. The code is more elegant. It uses some of the syntax that's more specific and friendly to Python. So the code starts getting a lot better. That's the key, right? So but this is nice and simple, right? So we can just run Jupyter notebooks and run these little cells, but it doesn't really build an app, right? That's not how you build the application. How do we do that? Once you get to the project, right, you want to take a look now at let me just close the PHP file. At the file called get code from issue, right? There is a generate code from issue file that is under the Python code generation folder, right? And this is the application. This is our driver. If you remember that flow, that workflow, this is what's going to call GitHub. It's going to call AI, and it's going to do its work, right? So this is a Python application that's really just importing the GitHub service, which is really is under the services folder. It's an implementation to call the GitHub RESTful API. And it's actually importing a factory service and AI factory service. And the idea here is that this code is, we can use a factory function to be able to say, I want to use OpenAI, or I want to use some other AI engine, right? So, but we create a function that says, hey, get me issues with a particular label. And we're going to take a look at that really quick. So what that does is just goes and it queries the GitHub service, passes that information to, gets a provider, the AI provider on line 41, right, based on the provider token, which is the label like Gemini or OpenAI, and then it's going to generate the code. It's actually going to call the service create with a prompt. It's going to get back that prompt, and it's going to just post it back to GitHub as a comment. Right. So basically, the way this works, if you're familiar with Python, is it has a main entry point that we can run from the terminal, and it will just get those parameters like the repo name, the label, and the provider. Right. So in this case, you will see line 89. You will see that's actually saying, "Hey, get this, run this code." Pass, use this GitHub repo, use this label, user story, and this provider, Gemini, right? So this is the sort of the application, right? But of course, if you look at the factory service, really what it's just really doing is, hey, let me just define some enums here for my different provider types, right? So this is open-ended. We can add more to it. And it says, hey, get me the provider, right? And it will say, based on the provider name, I'm going to map this to the one you need, whether it's OpenAI and so on. I'm going to resolve its keys, which is like the deployment key, the API key, the deployment or model name, the deployment or the model name, right, to be specific, and this a custom endpoint if you need to. So some of this stuff have a general in an API, but let's say if you're building your own application, you're going to end up building your own endpoint, your own API, right? It's going to say something like oscar.gemini.com, and it's going to be specific to what I need to build, right? So that is very important to understand, that there's the flexibility to do those things. But then it's just going to go ahead and return that provider based on that key, that model and that endpoint, right? And the way this really works is that, where the magic is that there is a base class, right? There's a abstract base class that gives it the same for all the different models to follow, right? The same. And this is just coding practices. It's nothing specific to AI. And then the Gemini service uses that base class for its API for the functions, right? For be able to implement the array function and be able to generate the model. But if you notice, this is similar to what we did in the Jupyter notebook, where we actually defined the model, define the key, and we're able to say define a method called create that's actually going to generate the content, right? And this is what this application basically will use in its code, right? But how do we do this magic, right? So key here was that when it comes to the repo, right? Let me just quickly switch to that. We go and we look at the issues here really quick. If you remember, the API says, give me a label, give me the repo, give me a label, and let me use that. So if you notice, that is the label. This label user story. So the way this works, if you're familiar with GitHub, is that you can label this according to what you need, right? It could be a test, could be a user story, it could be a documentation, a task, and so on. So, but you document this as a user story, and then that label is associated to the issue. So now when we call our GitHub API, we're saying, give me all the labels that are user story. And I'm just going to label that one because I don't want to, I don't want to spend a lot of time generating a lot of the code through our application, but essentially that's what this will do, right? So what this will do is we'll say, hey, run this code, give me this label, this repos with this label, right? And you will see here an example. So for example, I ran this earlier here, and what it did is says, hey, I'm generating the code from this repo with this user story, and this is the output, right? And so what you will do is you will run it here again, just like that. And the provider is the one that will changes based on the engine or the AI you want to use. But this basically does that, right? It's gonna say, hey, I'm sending a request, getting the user story, whether it's SQL query, a Python script, a React component, and so on, right? And it will generate it, right? So it's saying, hey, I generated something. This is my output, right? And look at how specific that is. See, it's actually creating like a common table expression and doing some select statements and stuff. And how does it know all that, right? How does it build all of that? So if you go back to the user story, and you can, what it basically does is saying here, let's take a look at this one. As a database developer, I need to create a complex SQL query that utilizes CTEs, right? Common table expressions, and join to extract and analyze data efficiently, right? So I'm building out the user story here, a way that is a very technical user story. Is really has a lot of the technical specification, right? And actually saying, hey, I want to use my data model is actually this table, the dimension for station, the dimension for booth, and I want to use a fact table called commuter, and I'm actually feeding some of the details for what that table looks like. So what are my requirements here to be able to do, right? I'm saying, hey, give me 2 CT. And this is where the magic is, right? This is where you need to be able to be detailed and specific and clear on what you want the model to do. So the model is not taking initiative for you and creating something for you. So perform a complex join between, right? And we're telling it to do all of this, right? Filter the data for year 2024 based on a particular field, calculate the total number of visitors, and so on. It's really giving it details as we think, right? As we're writing code, we sort of start thinking about these things. But we're writing the code, we're really not documenting. Here, we're really documenting so we can actually generate the code which I find very useful, right? In my career, I always found that it's really good to sort of brainstorm a little bit and think about what you're going to build before you start just coding away, right? So that's why it's good to document the code and so on. But here we're actually writing all this out, because here you're going to find hey, by the way, maybe this join is not going to work. Let me investigate a little bit more, right? This is where you're going to start thinking about it. But then tell the AI, hey, look, I want to generate this code here to use the CTEs and to achieve the joins I want, and the output should be clear. Table displaying the month, the station name, total visitors, and rank the top 10, right? And what you will notice here is that as we go through, and then you will see in the comments, right? And look at this 2 minutes ago, right? 2 minutes ago is what we just generated, right? The code that we executed just now generated this for us, and whipped it back to as a comment, right? So this is now where we actually get here some notification that says, hey, the automation worked. You got some code to review. Go through the review process, and if it's acceptable or not, modify it and apply it to the project, and then you do that. And you do the same for C#, Python, C++, and so on, right? So this works across all the different languages. The key here is to be able to tell AI, right? Even though it's AI, tell the AI specifically what you want to be able to do, so you're able to achieve this and get the result that you want. So with that, we come to a conclusion of this. I hope this has been very useful. Any questions you may have, please, you can use the Q&A. Any feedback, please review this project as well. If there are no questions, let me just continue to say this. Please join the AI engineering project, the machine learning project as well. Give it a start, please. We're trying to get this going and motivate it, build it out, build more use cases, and get some of the community to contribute as well, so we can build something very useful. But I hope you were able to enjoy this presentation. I had a good time explaining this to you. I only did a very high level overview of the AI large language models information. Definitely there's more to it. If you really want to get into it, if you really want to be sort of away and not get too deep into it, as long as you understand some of the software development practices, like, and follow the practices we already understand, which is how to write user stories, how to write requirements, and so on, you can leverage AI to help you do that in other things, not just software development, but other things, right? So a question is, how do we run this, right? So this, of course, for development purposes, you can run it locally. However, it does have a virtual environment. So if you remember, part of the code is that we use something called PIP, a PIP environment, right? So what this creates a virtual environment locally or on a VM, right? So if you want to push this to a VM, right, or if you want to use, for example, GitHub, I forgot the name, code space, GitHub code space, which is a VM. The moment you run this, it creates a bubble. It creates a virtual environment within your target, whether it's your local station or your VM or what have you. Thank you for the question, Fabian. But please play with the project. Is there. You have a C# example as well. We have other examples coming in using TypeScript, JavaScript, Node.js. So please follow it. And I thank you for joining us today. Please follow our chapter and give us a star on the repos. Send us any questions on GitHub, please. Send me questions on Twitter if you want to. Best way is if you go to the repo, GitHub repo, and open an issue with the questions that people can read and learn from your questions and responses. That's the best way to do it. But wait for the email after the presentation. I'll be sending you in the next couple of days all these resources the presentation and the video that's being recorded on YouTube. Thank you, everyone. Enjoy and have a good rest of your day. Thank you, Leo. Bye-bye.